For our last major theorem of the semester, we are going to be looking at the intermediate value theorem. Now remember, in this video, we're just going to be conceptual, right? We're not going to dig into the proof quite yet. So we're going to develop some intuition around the intermediate value theorem, why it might be true, what it might actually be. And then we're going to go ahead and state the theorem. Then I'll let you work on the in-class activities, and then we'll come back with a proof of that theorem. So suppose you have a continuous function where f of 1 is equal to 5 and f of 3 is equal to 1. The question is it possible to avoid having 2 in your range? Keep in mind this is a continuous function, so conceptually just means that there aren't going to be any breaks in the function. So here's what the graph looks like. So that blue dot up top, that is f of 1 equals 5. The blue dot on the bottom, that is f of 3 equals 1. We are going to draw a graph between those 2 points, and we're going to try to avoid having an output of 2. So we're going to draw this nice little horizontal line here at y equals 2 to show us that we can't hit that dashed line. We've got to stay away from that dashed line. So we can try going away from the dashed line if we want. But remember, we eventually have to go back down. We have to end up at x equals 3, y equals 1. So at some point we have to go down. And as much as we try to avoid that y equals 2, if we want to avoid any breaks in the graph, we're going to have to cut through it at some point. And where it cuts through that dashed line, aha, that's our input. That gives us our output of 2. So the way we have it drawn, f of c equals 2. So the answer is no, we can't avoid having 2 in the range. And we can generalize this to what is called the intermediate value theorem. Let f be a function whose domain is the closed interval a, b, and whose codomain is the real numbers, and assume it's a continuous function. And let d be some number that is between f of a and f of b. So in other words, either d is greater than or equal to f of a and less than or equal to f of b, or d is greater than or equal to f of b and less than or equal to f of a. Then there is some c in the domain such that f of c is equal to d. So that's our theorem. The in-class activities are going to help you develop some of the intuition to understand the proof. Go ahead and work on those. When you feel like you understand those a little bit better, then you can dig into the next video, which gives a formal proof of the intermediate value theorem.